Hi, welcome to our channel Good New. With the development and popularization of Huawei and ZTE's telecommunications technologies in recent years, more and more Chinese people have become aware of 5G networks and have begun to replace their mobile phones with mobile phones that support 5G networks. The launch of 5G also heralds the start of an age of ultra-fast cellular data transmission, but getting the technology to live up to expectations is a massive challenge that will necessitate significant modifications to the whole semiconductor ecosystem. 5G is essentially an advancement of 4G LTE. Millimeter wave technology is the main promise for leveraging 5G to accomplish breakthroughs. Because of their higher frequencies, millimeter wave signals attenuate faster and are more sensitive to interference from numerous forms of noise, objects, and even environmental factors. So, what are the current hurdles to popularizing 5G? The first type is physical interference. As 5G chips become more heterogeneous and antenna arrays are implanted into sophisticated packaging, the test procedure necessitates more insertion points and therefore more time, increasing chip cost, EMI, nonlinearity, and various forms of noise have emerged as major concerns for mmWave devices. These signals are more vulnerable to interference by definition, and the effects are magnified when chip dielectrics thin. Furthermore, when chips are crammed into smaller places, EMI from PCBs becomes a concern. The industry is only now beginning to investigate mmWave signal integrity in urban settings, including the impacts of vegetation, weather, buildings, and other things. The issue is that various frequencies behave differently, and frequencies might differ across nations or even within the same country. This makes modeling and simulating these devices extremely challenging, because what works in one location may not work in another. The second type of modification is the result of testing. The key issues of mmWave are determining what to test, and what to do with the results once the test is over. This is exacerbated further by the fact that mmWave testing incorporates RF and digital circuits, as well as novel materials and packaging approaches. While mmWave research has been ongoing for some time, the semiconductor industry is just now beginning to investigate the dependability and quality of service of this technology in the real world. For mmWave, OTA testing is crucial. Millimeter wave needs collecting the radiated signal in the air, i.e. OTA testing, which is different from earlier 4G per 3G testing, explained George Herdarte, wireless product marketing strategist at Teradyne. There is now an antenna to receive the signal and subsequently transfer it to the ATE, as well as test instruments. This is a trend that will become more evident as it hits 6 GHz frequencies. The distance between the test chambers will be shorter with additional antenna components, favoring OTA. All of this affects testing and makes judgments about what to put in hardware against what to put in software, what to use analog versus what to use mixed more difficult. The trade-off is that hardware is quicker and uses less power, but software is more flexible. Analog can be calibrated and modified, but digital is typically set. Calibration is essential throughout manufacturing, and calibration tables that characterize performance at different temperatures are stored, said Peter Clayton, CEO of Picocom, which manufactures 5G baseband SoCs. Calibration in RF and analog involves digital predistortion. In the digital age, on the one hand, additional work in the design process utilizing EDA tools is required to reduce potential violations or failures. We used to be able to tape out the design, place, and route in a week, now it's 6 months later. Tape out since there is still a lot of back-end testing to complete and a lot of locations to rewrite at the same time. The third factor is the life cycle. Typically, they are pricey chips and tiny cells are scarce. So, if their conduct becomes strange, our purpose is not to discard them, but to watch their behavior throughout their lives and adjust them wherever they go. If a 5G chip produces unexpected outcomes at work, it must be given back into the production process. It's amazing to watch what's going on in the factory. Many variables can impact performance, including age, which causes drift in analog circuits, electromigration in digital devices, and software incompatibilities that accrue over time and a series of upgrades. We can detect critical system-level parameters over time. The average latency on a key link, for example, rises over time. If you can create a normal picture of expected functioning, you can determine when to start sounding the alarm that a software upgrade is needed. We can gather this data over time, store it in a database, and then evaluate it. This simply adds a new dimension to testing and represents a potentially profitable new business opportunity to gather and analyze data to understand what's going on within the chip and outside the system. This is especially true for 5G baseband chips, which can service many clients under varying situations. The SoC may execute software for many operators at the same time. It may operate in many frequency bands, and different consumers correspond to various scenarios. It isn't a semiconductor with a single software load that always does the same thing. Every client uses it in a different way, therefore it's critical to be able to monitor what's going on and troubleshoot it in the field. The fourth challenge is the chip inspection and metrology challenges. Packaging is one of the most significant modifications in 5G. There are many dies in addition to the antenna implanted around the package, which add mechanical stress, exacerbate process variance, and cause burn-in issues since not all dies age at the same pace. In the past, if the data was excellent, the package was acceptable, said Oris Donzella, a software engineer. KLA's Electronics, Packaging, and Components Group Executive Vice President. Heterogeneous integrated packaging: if one of the dies fails, the entire package fails. This has significant economic, safety, and dependability concerns. For example, the yield for a single die is 99%, and there is no issue with a single mold package, but, for 36 dies, while the yield rate of each die is 99%, the yield rate of the overall package is only 69.6%. Because of the higher frequencies, more components on the RF side are necessary. Increasing equipment costs also necessitate comprehensive inspections to guarantee that individual components, as well as SoCs, packages, and boards, are free of crucial faults. This enables the employment of instruments like atomic force microscopy, AFM, more viable, both in terms of device and time necessary to complete a more in-depth inspection. Rising prices have also enabled optical inspection coverage to be expanded. Lens sizes and speeds vary greatly amongst chips, with modern packaging falling somewhere in the center. The need for testing has grown as a result of growing expenses. Due to the poor yield of very small and complicated components, 100% inspection is essential. To summarize, one of the major developments in 5G technology is that data is becoming increasingly important in detecting flaws throughout the process. Data may be used to discover possible problems on the verge of becoming true defects, as well as to monitor performance deterioration or aging on hardware and software. The data from mmWave may also be used to bend signals around obstructions in order to keep devices linked. More study on the supply chain is also being conducted. There is little question that millimeter wave will become mainstream in the next years, but how to secure its long-term stability is unclear. The tools and methodologies are either in place or in the works, and the whole 5G ecosystem is rushing to expand the knowledge base in order to make the transition as smooth as possible. Thanks for having your watching in this video. You can add your ideas or suggestions below. Please keep following our channel and like our videos.